I'm a blue coat here at home. And today, I want to talk to you a little bit about pulleys. Now, I'm going to talk a little bit about pulleys, explain them, and set you off on an activity. So in order to do this activity, you'll need a few things. So in order to participate in the activity, you'll need a long stick or pole, like a broomstick or like a mop handle. That also works. You'll need a long rope, probably at least 3 meters or longer if possible. You'll need an object to use as a lifting basket, like a lunchbox, something with a handle, a toolkit, can caddy, and objects to use as weights, because we want a little bit of weight. We want our lift to feel a bit heavy. So here I have a few examples of things that you could use in this experiment. So the broomstick, the lunchbox, the rope, water bottles, just a few different things. So before we get started with pulleys, what do I want you to know about pulleys? There's 3 things that I want you to know about pulleys. 1, pulleys are a simple machine. So there's 6 different simple machines that exist, and pulleys are a specialized wheel. And so they help us to do different kinds of work by lifting or lowering different things. So let's look at a few pulleys that we might encounter in real life. So here we can see a clothesline. It's always used as a good example of a pulley. It helps us to sort of shimmy laundry out away from the house so that it can dry. Another really great example of a pulley system, or an object that uses a pulley system, is an elevator. So on the inside of an elevator, or actually on the outside, on the inside is where the people are, on the outside is where sort of in the shaft is where the mechanism is. And the lifting is accomplished by a series of cables that are able to lift up the people and the machine. So that helps people who may not be able to walk upstairs, and it makes sort of the work a little bit easier. So another cool and fun example of a pulley that I found while I was searching around the house for pulleys was a fishing rod. So fishing rods are kind of cool, and a lot of the simple machines that I found are like combinations of different simple machines. So the reel here is actually a pulley, right? It helps us to pull up the fish, but the fishing rod itself is actually a lever. Also here, when we turn, this is also a lever on the reel. So that's kind of a fun and interesting pulley system. Now you might be wondering, what is this little machine behind me? I chose to include it here because it's kind of a neat pulley system, something that we don't really see every day. So the machine here is made to draw on the wall, and the way that it can tell its position is by using 2 pulleys on both sides of the machine. So while my machine is finishing to draw its picture, I thought I would expand a little bit on what I mean when I say that pulleys can make work easier. So I've got some pulleys here, some different ropes, and this object here, it's called a Newton meter or a force meter. So what it does is it tells me, I weigh something, I put a weight here, I put a mass. It tells me how much force is required to hold this object up. So essentially, the only force right now that's pulling down on this weight is gravity. So in order to balance out gravity, this hook has to provide as much force to keep it from moving, to keep it stable. So we can kind of conclude that the force, if the force pulling down is gravity, the force pulling up is this hook. The force of the hook is equal to the force of gravity. So right here, this scale is measured in newtons. We can see that this 500-gram weight requires about, that's 2, 4, right about 5 newtons of force to hold it up. So let's see how the force is impacted when we want to lift something with a pulley system. So let's see what happens here when I lift the object a little. So really not much happens to change the force there. So I want to lift this now. Rather than just using my hands, I'm going to lift it using a pulley. So I set up a simple pulley system here. We've only got one pulley, and I've got the force meter, the Newton meter. Unfortunately, it's upside down right now. I'm using it a little bit differently than it's kind of meant to sort of be. We can still use it though. So what I want to do is I want to show what happens when I'm lifting that pulley. You can see the pulley there. Does the amount of force change? So actually, it looks like I need about 6 newtons of force here in order to lift that pulley. But I've actually added something. The weight of this meter is now into the system here because this has to hold this up from gravity as well. So it doesn't quite seem like it's getting easier yet, though the wheel does help to lift, and it gives a little bit of an advantage because I can stay at the same height and still lift an object higher than me. So let's add another pulley and see what happens to our system. So I want to try a system that has 2 pulleys. Now, in order to have a good comparison, I'm going to add at the bottom here the weight of another pulley into the system. So let's see, okay, remember that's still about 5 newtons. And when I add this pulley on, like a little bit past 6. So adding the weight of an extra pulley adds to the force required to hold it up. So another thing that I had to do here, I needed to use a longer rope. So when we're adding pulleys into our system, sometimes we need more rope in order to do that. So I'm gonna just string this pulley in the bottom and hook on the weight, put it up through to this pulley. And now you can see I can lift up that weight. So what does our force meter tell us now? Let me just move up a little bit. So this is actually pretty cool. We can see now that when I'm pulling down, it actually I only am needing about 4 newtons of force to lift that pulley up. But again, you'll notice that I needed more rope. So the last pulley system that I want to experiment with or show you right now is the last one. It's got a double pulley system. So it's got a double pulley and then another pulley here at the bottom. So again, I've got that weight, that mass, so my ropes are a bit twisted. And does it make it easier, again, to lift it now that I sort of have, so I've got the 2 pulleys on top and then 1 on the bottom, so I actually have 3 pulleys in this system right now. Now, one of the things about science and physics specifically is that there doesn't really exist a perfect system. So yes, in essence, pulleys are going to help me to make this movement easier, but if I don't have the right size of rope or the right size of pulley, I might be getting too much friction. In fact, something funny, when we do calculations with pulleys, we imagine them to be frictionless, even though that's not really possible. So I'm noticing I'm getting a little bit of friction here. The rope just fits just perfectly inside those pulleys. So if it gets pulled off a little bit, then I'm not making the work really that easy. So we can see the rope kind of gets caught. So yeah, in theory, when we add more pulleys to a system, it should get easier and easier, but we need to have the right tools for the right job. And I found this rope at home and this little pulley might not be the best combination. So when we're talking about work, when I say pulleys like make work easier, work, when we're talking about work in science, it's not exactly the same kind of work like we talk about like your job. It's not quite the same thing. So in science, in physics, when we're talking about work, we are talking about the product of the force times the distance. So in order to have work accomplished, there needs to be a force exerted and it needs to go over a distance, which again is a little counterintuitive to what we know about work in our, let's say, normal language, which is a little bit different. So I'll give you sort of an example. If I'm holding on to something heavy, I'm just holding on to something heavy, it's hanging. My body feels like my muscles are working. So I might think that I'm doing work, but so long as that object isn't moving, no work is done. So the work was done if I picked it up off the ground once I lifted it. Okay, so I exerted a force because I had to go against gravity to lift it up, and it traveled a distance. So that's what we're talking about. Now you noticed as I added pulleys, I had to add more rope. So the force that I'm exerting has to travel over a longer distance in order to make that work sort of feel easier. Now we got to be careful when we say work feels easier because that's not really quantitative and scientific. It hasn't got a unit of measure. So yes, that is true, and we do want to use it to sort of give us a feel and help us out. But we need to kind of know that it's not the most scientific way of referring to things. But we do want to have a chance to try and explore pulley systems. So the next thing that we're going to do, we're going to move over to the activity. So we relocated to the kitchen because it's the best place I found to try out the next activity. You'll need these items. In addition to those things, you're going to need to find somewhere stable where you can prop up your broomstick. So I tried this out on 2 chairs. That kind of worked. The chairs were a little bit low. I tried it out on 2 stools. That also worked. I needed a couple of extra helpers to hold on to the broomstick to make sure that it stayed stable. And the last place I found, and the best place, actually has been to prop the broomstick up onto 2 drawers. So that works for me in my kitchen and also in both of my bathrooms. So let me show you how to set it up. So when you're setting up this activity, and when you're setting up all science experiments or in life in general, you want to make sure that you're being safe. So you're going to choose a weight that's not too heavy, but it's still going to let you feel the difference of force by wrapping the rope around. That's what we're going to do. We're going to change the rope configurations to feel how it would be to make like sort of a pulley simulation. So you want to choose something that's heavy but not too heavy. For me right here, right now, the water's a little bit too heavy. I could pour some out, but I wanted to show you some other examples. I put some soup cans here in this little box, so that added a little bit of weight. The drill is heavy enough, and it's nice because it already has the handles here. And the lunchbox, well, I could put the weight in there and use it as well. So you want it to be heavy enough, but not too heavy. Now, the point of the activity is not to throw things around and make a lot of noise or really break anything. It's really to explore those different pulley systems and how different forces, different directions of forces, how they affect the end result or like the effort, let's say. So you've got your basket choice, your weight choice. The next thing is where you're going to choose to set up your broom. Now, throughout this process, right about now, you'll probably want to get an adult on board. You'll want to make sure that they can also double check that your setup is safe. Now in my case here, I'm gonna be pulling down on the broomstick. So this cupboard is stable, it can't move. I wouldn't do it on a dresser that could topple over. In my house, I mentioned earlier, I have a couple of drawers in the washroom that could work well, or on a chair. Just make sure that it's not going to tip over. So you don't want to pull the drawers out too far. The further you pull them out, the more likely it is that you can damage things. So you just want to pull it out just far enough so that you can string your rope around it. So I have a little clip here. You really don't need the clip, but you can tie the rope to the basket. You want to tie the rope to the basket. I'm just going to clip it on here. Then I want to sort of familiarize myself with the weight of the basket. How does it feel to me to pull it from the ground? It's on the ground, sorry you can't see it. Okay, and then lift it up. Just to kind of get an idea, just to get a feel for the amount of force that it takes for me, okay? And then the next thing is we're gonna string it over the broom and see how that feels. Okay, so I moved here so that I could show you how to string the rope over and use the broomstick like a pulley. So another thing that I did here, I made a little mark. So I took a marker and I made a little mark right here so that I could tell the distance. Remember that we were talking about work, and work is the force times the distance traveled. So the distance that our basket is going to travel is going to be the length of that rope the first time. So another thing I did, you might notice I taped up here, my basket kept getting stuck on the handle here. It works a little bit better, it's still not perfect. And of course, nothing about this system is really perfect, it's a simulation. So remember I tested out earlier how the basket felt. Now what I want to do is pull it upwards. So see if it's getting stuck there. So to pull it upwards and see, okay, how does that sort of feel? Okay. Again, it's not quite a perfect system. But what I can do from this point, I can add a loop onto this. So that way I can see how it would feel to add another pulley. Remember that as we add pulleys into our system, the distance that we have to travel is a little bit further. Okay, and we're going to make another mark afterwards. So see, now I wrapped around one more time, and now I'm going to add the clip. Now I'm going to pull. Now the thing is, it's very, 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 very easy to pull the rope now. Very easy. But you'll notice that the distance that I had to travel was much, much further. So the force, the actual distance that the basket traveled was the same. But where I was pulling, the force that I exerted along the rope was a little bit further. So I'm going to take that mark down and say, let's say I pulled from here. Now another thing that you might want to try to do is sort of experiment with the direction of the force. So is it easier if you pull straight down? Can you pull straight sideways and still lift your basket? And what happens if, let's just say we were to add another loop? Would it make that lift even easier? Let's see. So, back through. So you'll notice again, I'm using a lot more rope. Okay, so now I'm hooked in. Now you'll see I've got the rope looped several times. And again, it's a lot easier to pull up. Each pull is, it's like less effort, but actually the distance that we traveled is a lot further. So I'm just gonna unhook the basket now so I can check out the difference in between the distance that actually the basket traveled compared to the distance that the force that I was pulling on was. So this was that first length here. Now if I keep going and find the other mark I made is right here. So actually it's that distance was quite a lot different. So this is a really neat activity because it really allows you to feel the difference. Now again, this is not an ideal system. It's not perfect. It's a simulation. It's sort of to give you an idea of what it would feel like. But it does really get that idea home. Cool. That was fun. We're almost in time to see my robot finishing up its drawing. So 3 things to remember about pulleys. Pulleys are a kind of simple machine. They are a specialized wheel, and they help us to lift or lower things. So there's tons of different applications where these pulleys can help us out. So they're actually pretty awesome. Sometimes they can help us to use sort of less force in order to lift things, or sometimes they can help us to lower things more slowly. There's a lot of different recreational applications. So where we're using pulleys kind of like for fun, like in rock climbing, or there's a lot of like gym equipment that uses pulleys and weight systems to work out different muscle groups. So that's kind of cool. There's also, other than like our recreational applications, there's a lot of industrial applications where we're using pulleys in industry to lift crazy big things like hoists or cranes, or we use pulleys to hoist up like fishing nets. Lots of different applications in industry as well. So I hope that you had a bit of fun today. Maybe you learned a thing or two about pulleys. I hope you try out the activity. Keep being curious. Let us know if you have any questions. Thanks so much for joining us here for Science at Home.